Good evening, I'm Dhruv Agarwal and I'm going to share my final year college project, which is developing a machine learning based web application to predict the remaining useful life of a mechanical component. I wrote all the code for my web application on VS Code software. This is the code for my web application. It includes both the front end code and the back end code. The final web application for my project looks like this. I have also integrated 3D models with which user can interact, rotating the model, moving it up and down and left and right. Then there is a brief introduction about what I'm focusing on in this project and what is the impact of my project. The impact is this: it has been reducing the downtime, increasing lifespan, increasing safety, and operational efficiency of a component. This is my project timeline. From week 1 to 4, I focused on collecting dataset. The main website I used for collecting dataset was kaggle.com. From week 5 to 8, I focused on training and testing my model. For that, I used Google Colab. Battery RUL.IPNB is the model I use for predicting the remaining useful life of my battery component. With the time engine, I use this model to predict the remaining useful life. For checking the accuracy of this model, I used MAIT because I am using regression models, and as we can see that in the regression model we assess the accuracy with MSE, root mean square error, etc. And in classification models we use metrics like accuracy, precision, etc. So in my model below, here is list of components for which a user can predict the RUL, and below the is a form with in which user can enter his or her name and email address, and the will reach my email, and I can see the message or what the user is filling the form for. Also, here is another 3D model with which you can interact. When we click on this engine component, we are redirected to a different page where we can predict the remaining useful life for engine. Here are some prevention which we can take so that our engine runs longer, and here are some causes which results in failing for the engine. Here we can enter specific values for unit number, timing cycles, operation setting 1, 2, and 3, and some sensor values, which after entering which we can predict the remaining useful life. And as we can see, our predicted remaining useful life is 165.99 cycles, and total life of the engine is 167.9 cycles. Here is a graph for more visually appealing way of presenting the information. Similarly, we can also click on the battery component, and it will also direct us to a different page on which we can predict remaining useful life of battery. And for predicting that, we have different parameters like cycle index, discharge time, decrement, max voltage discharge, minimum voltage charge, volt, time constant current, and charging time. After entering the parameters, we can click on predict, and it will give us the predicted remaining useful life as 1109.61 cycles. And as we can see, the total life is 7,000 cycles. So this was my final year college project. In this, I use different algorithms and different. Also, I make the use of JavaScript Python, React, and Flask for creating API for my model to build this entire web application and this project.